In this example, we will antidifferentiate the function x divided by the square root 1 minus x to the fourth. Now, my initial thought looking at this is to proceed through the strategies of integration that we have. I see no obvious algebraic manipulations or necessarily good obvious substitutions to get started. Additionally, it doesn't fit any of the standard forms that we have. But there is a maybe slightly more subtle substitution. Looking at that denominator, 1 minus x to the fourth, and thinking about what we have left over, this x dx. If we somehow wanted to use that x dx as a du, we would want our u to be x squared. So with that observation in mind, we can think of x to the fourth as being the quantity x squared squared. And that allows us to see that there is maybe a substitution here that could work. So this is the antiderivative of x divided by the square root of 1 minus the quantity x squared squared. So a very reasonable substitution then becomes u equals x squared. So that du equals 2x dx, or stated differently here, 1/2 du is going to be the x dx we have in our integrand. So expressing our integrand solely in terms of the variable u, we have a 1/2 that pulls out front, then it will be the antiderivative of 1 over the square root of 1 minus u squared du. And at this point I would note that I think we've taken care of the most difficult part of the problem. Looking at the integral and somehow deciding upon a strategy and going into it enough steps to at this point see that this is an antiderivative that we can easily evaluate. And when I say we can easily evaluate it, it is in fact just one of our common antidifferentiation formulas. The antiderivative would just be arcsine of u. And the last step would be to resubstitute. The original variable was stated in terms of x, so we replace each of the u's with x squared. So this would be 1/2 arcsine of x squared plus c. Now, a good big picture observation to make here is that at first there may not have been an obvious substitution, but thinking about what could be a good thing to play the role of the du, x dx, that led us to think about the substitution x squared. So that can always be a good perspective.